Okay. Hello dearies, this is Miss Medina and we're going to record a video on algebraic expressions. You need to be able to identify the terms, the factors, the coefficients. In context means related to a word problem. An expression that contains letters, those are variables, numbers, or operating symbols like addition, subtraction, multiplication, and division is going to be called an algebraic expression. And an example of an algebraic expression, the expression doesn't contain the equal sign. We usually reserve that for the equations. An example of an algebraic expression would be 5x plus 7y minus 3. It has variables, it has numbers, and it has coefficients. And I'll teach you how to identify those right now. So in an algebraic expression, we have four different parts. We have the coefficients. The coefficients are going to be the numbers in front of the variables. So in this case, it's going to be the 5 and it's going to be the 7. All right, so it's just the numbers, the 5 and it's also the 7. We have variables. So the variables are going to be the letters in the expression. And in this case, it's x and it's also y. We're also going to have constants. Constants are the numbers that don't have variables. So in this case is the -3. And I think I forgot to highlight this. Ooh, oops. And the terms overall are going to be those that are separated by a plus sign or a minus sign. And they can be numbers and they can be variables. So we have one plus sign right here and we have a minus sign. So this is considered one term, another term, and another term. So we have three terms in this expression. We have 5x, we have 7y, and we have -3. Factors of each term are the numbers of expressions that when you multiply them produce that given product. So in this case, let's say 5x, the factors are going to be 5, it's going to be x, and they can also be together 5x, okay? So looking at the first expression, which says 2x plus 5z minus 3. We want to list the terms. Remember, the terms are the ones that are separated by plus or minuses. So the terms are 2x, 5z, and -3. We want to list the factors of the first term. Well, the first term is 2x. And what are the factors? The factor is 2, and the other factor is x, because when you multiply them, you get 2x. We want to list the coefficients. Coefficients are going to be the numbers in front of the variables. Looks like pond in front of the variables. So in this case, it's going to be the 2, it's going to be the 5. We want to list the variables. The variables are the letters. Let's put that in quotation marks, because, and in this case, the letters are the x and the z. And the constants are going to be the ones that don't have any variables. So this is numbers only. So in this case, it would be -3. So how is that? Let me go ahead and write down what the terms are. These are the ones that are, okay, so these are separated by pluses or minuses. All right, here we go again. 13. So while you may not consider 13 an expression, 13 is an expression. There are no pluses and there are no minuses. That's because there is only one term. 13 is the single term. What are the factors of the first term? Well, the factors are going to be 13 and 1, because when you multiply those two, you get 13. Coefficients, there are none. Because remember, the coefficients are going to be the numbers in front of variables, and we don't have variables. And the constant is the single term, which is 13. All right, let's do this one. Now this one's a little bit longer, so let's just make sure that we're patient. 6m to the third minus 9m squared plus s minus 4. So the question is, how many terms do we have? The terms are going to be the ones that are separated by pluses and minuses. So this is one term, that's another term, that's another term, and that's another term right there. So we have 6m cubed negative 9m squared s and 4. The factors of the first term is 6m cubed. So the factors are 6 and m, I guess 3 times. Because when we multiply them, we get 6m cubed. Oh, I guess we can break down the 2 and 3 with the 3m's, right? All of that multiplied will give us the 6m cubed. The coefficients are the numbers in the front of the variables. So that would be the 6. Now this is tricky. It's not just 9. You got to bring the negative sign with you. So it's -9. Right here, it's invisible, but it's an understood 1. All right, so the coefficients are the 6, the -9, and the 1. All right, so this example is supposed to show you, don't forget your negative sign, and don't forget that in front of the variables, when there is no number, is an understood 1. And the variables are going to be m and s. We don't have to list m twice. And the constant is the number at the end, which is your -4. Okay, let's do this again. How many terms do we have? In this case, this is x squared plus 7x minus 1. So we have 3 terms. We have x squared, we have 7x, and then we have the 1. It says to list the factors of the first term. Well, the first term is x squared, and what 2 things do we have to multiply to get this? It's x and x. So those are your factors. The numbers in the front of the variables. So the numbers in front is going to be here and here, all right? Because those are the 2 variables. Now you're thinking, you should have learned from the previous example that when you don't have a number in front, it's an understood 1. So the coefficients are a 1 and a 7. The variables are, there's only one variable, x, and the constant is -1. All right, so in this section, we're going to combine like terms. What do we consider to be like terms? That would be the ones that have the same variable, and the variables are raised to the same exponent. Terms with the same variable that is raised to the same exponent are called like terms. For example, 3x and -7, while the coefficients, the 3 and the -7 are not the same, the variable is the same. This is x raised to the first power, and this is also x raised to the first power. The second example, the one here in the middle, all right, 2y squared and 6y squared. Make sure that you're repeating this as you're watching the video. You have to get comfortable reading these expressions. So the coefficients are a 2 and a 6. They don't have to be the same, but the variables have to be the same, and they also have to be raised to the same exponent. Y raised to the second power is the same as y raised to the second power. So these are considered like terms. So this is a not like example. This is a non-example. So we have 4x and we have 6x squared. Why? Because over here, x is raised to the first power, right? And over here, x is raised to the second power. So the variables, you're writing this, have different exponents. The base is the same, but they have different exponents. All right, directions, simplify the following expressions. Simplify is going to mean combine like terms. Until you can't combine no more. Combine like terms, and remember constants are like terms. So you have negative 3x and you have 6x. They both have an x, and both x's are raised to the same power. This is x raised to the first power, x raised to the first power. So they are like terms. So what you want to do is you want to focus on the coefficient, and this is technically, this is what your brain should be identifying this as, negative 3 plus 6 with your x at the end. And when you combine those, you're going to get 3x. All right, so all you have to do is worry about the exponents. Negative 3 plus 6 is going to give you positive 3. Right, and you have to carry the exponent with you. Same thing here. Which ones are like terms? Let's use a little bit of this is y raised to the first power, and this one right here. But look what I did. I highlighted the negative sign. The negative signs go with the term that follows it. So in this case, you have a 1y, correct, and a negative 2y. So you have to think about your exponents. I'm sorry, your coefficients. You have negative 1. Ooh, you have a positive 1, and you have a negative 2. Put that in your calculator, you're going to get a negative 1. So y minus 2y is negative y. And then what do I do with these, Ms. Medina? Well, they're technically like terms because they're constants. And negative 3 plus 6, and you can look at it this way as well if you want to. But the 6 is bigger, so it's going to give you a positive 3. So plus 3. I'm probably making it harder than it seems, but here we go. All right, here's another example of difficulty. So I hope you're paying attention. Each of these were chosen so that you can see the different ways that the problem is going to be given to you. Now, when you look at this problem right here, not only do we have two different operations going on, you have the plus sign in the numerator, and then you have the fraction bar, which is technically division. So you should see this as 4x over 2 plus 6y over 2, and then minus 3y. All right, so now let's simplify. This is a fraction 4 over 2, right? If we divide both of these by 2, oops, my bad. I wrote it in front of it. I'm not sure what I was thinking. 4 divided by 2 is just going to give us 2, so that'll become 2x. And then 6 divided by 2 is going to give us 3, so that's 3y, and then minus 3y. Now here's another example, something that is potentially going to happen. We can tell that both of these have a y raised to the first power. But look at their signs. This one is a positive sign, and this one is a negative sign. So they are opposites or inverses of each other. So they're going to cancel. Another way to look at it is positive 3 minus 3 gives you 0. And 0 means that the term goes away. So your final answer is just the 2x. Number 4, we have more terms and different variables. I see an m to the first power, and this variable is different. This is n. So these are not like terms, and we cannot combine them. So you need to be careful, you need to make sure you're paying attention. But this -3 and this +10, they are like terms because they're both constants. Okay, so you have to think about it like this. -3 plus 10 should give you a +7. So we're going to carry this one and we're going to carry this one since we can't combine them. 8m plus 1n plus 7. Miss Medina, didn't you say that we don't write the 1 when it's in front of the variable? And you are correct. So a more acceptable form would be this. This one, 9x minus 10x squared plus 7x minus 3. So technically we have 4 terms, right? The 9x, the -10x squared, the 7x, and the -3. Which of these terms are like terms? So it's going to be this one, and it's going to be this one. Now pay attention, this one is positive, it's a +9, and this is also a +7. So your brain should be thinking, oh, +9 and +7 make +16. So this becomes 16x, and well, all I gotta say is that this one and this one are not like terms, so we just bring them along for the ride. Why didn't I put a plus sign in front of the 16? It's one of those things in math where we just understand it to be a positive number. Right, once again, multiple things going on. The first thing you want to do is you want to simplify. You want to get rid of your parentheses of your fractions if possible. And in this case, we have an x, we have a y, but we also have x and y in here. So let's go ahead and split this fraction. Each of them gets an over 3. Okay, we're still simplifying. When you get really good, sometimes you can simplify in one step. 3/3 becomes a 1. And remember, we don't write the 1. It's just a 1. Okay, that's an understood 1. -9/3 is -3. And don't forget the y. All right, so now that we have it simplified to this point, let's find our like terms. This one and this one, they are both x to the first power. So x plus x, once again, you're thinking about the coefficients. Remember, the coefficient here is a 1 as well as over here. And so your brain is going 1 plus 1 is a 2 mix. So we have 2x. And then looking at your +2y and -3y. So then your brain goes +2 minus 3 and -1 makes. So that's -1y. But Miss Medina, didn't you say that we don't write the 1? You are correct. A more acceptable answer would be this.